So yeah, I'll just do a quick introduction to me. I'm Kari Lawler, and I'm the youngest startup and entrepreneur over at the Innovation Birmingham Centre, which is just down around the corner. And so that's my company, Lawler Industries, and I do AI consultancy for companies around the building. So what is object detection? Quite simply, object detection is a computer technology related to computer vision and image processing that deals with detecting instances of real-world objects such as humans, buildings or cars in digital images or videos. So we've got like examples of what object detection is with accuracy rates on them as well. For my demonstration, I've been using the Tensorflow object detection API, which is the easiest way I've found of doing this. And I just decided to build a simple base model just to show of a porg detector, because they were my favourite part of the new Star Wars movie. And because I was just training my model with a single class and with minimal training data that I collected myself, I just decided just to do transfer learning and load in a pre-trained model and then just add my class of porgs onto that. I chose just to load in the Coco RCNN model due to it being very fast. However, with this model, the drawback is it is slightly less accurate than just using some of the other models. The Coco model is the Common Objects in Context. It's just an open source Microsoft model. I think it took over 100,000 or 10,000 man hours to collate all the data and label loads of different objects. I think in this case there's 100 different classes. But there is other models that can be used, such as Inception and ResNet, which have different accuracies from different things. I just put a little bit about RCNN models, which are region-based convolutional neural networks. So pretty much it's just a model that firstly identifies regions of interest in a photo and then runs convolutional neural networks on those regions to pick out where the actual bounding box is or where the actual object detection is going to work. Step one in the process is labelling training data. And unfortunately, collating the data is quite a manual process. And I decided just to do it manually through Google Images. But it does involve as well labelling data for this, because I was only building like a very basic model. I only collected 150 images of porgs and then used the label image software just to label them all manually, which took about 2 to 3 hours to do. And then to make it compatible with my actual model, I had to convert them first because when you run it through the thing and do the labels, it saves it out as XML files. So I first had to convert those into one CSV file, one for training, one for testing data, and then convert that into TF records to fit in with the Tensorflow to be compatible. And this is just an example of the porg that I labelled and doing it in the training data, so I had to go through and do that 150 times on all my images. So for this I just used some of the test scripts that were on the Tensorflow GitHub pretty much just to run this as a basic model. And this is it's quite awkward in the fact that everything has to be in a very specific directory structure to do this, so it takes a lot of train tests and stuff, and because it runs as an API, it has to be loaded properly and files have to be exported and stuff like that, but that's quite complicated. I just ran, just to train the model, I saved all my data and then just ran the configuration file that came with the Coco model to run that, and then I trained this on my NVIDIA GTX 1070 GPU, a single one. It took me about 3 hours to get a loss function that I was happy with on that, but I'm pretty sure I could have trained it for less time and got about the same accuracy. And then testing the model. Once the model was trained, I just exported the inference graph that was saved out and then ran some test images on it. And it was running and testing the images, which I'm going to show in a minute. And given like the small amount of training images, because I only did 150, it was doing it pretty accurately. But of course, with more images, better models and stuff like that, it would probably have a much higher accuracy than what I did get. Oh, so I'll show you my actual model now, sort of. I'm going to show you that's kind of what it did in the end. So it just picked out the porgs in the images and did sort of accuracy percentages of how likely they are to be porgs, even though, as you can see, it's not brilliantly accurate. And then I had some problems as well because I tried it with some other birds and it still thought they were porgs, but it had a lower accuracy. So whereas with the porg up above it said 99%, it's got 61% there. But I'm pretty sure if I did train it more on more images and maybe trained it on different birds, it would get better than that. And then go back to my PowerPoint. Oh, it's gone. It started from the beginning. Wait a second. Oh, and then oh gosh.
Just click on the slide.
Yes, I'll just click on that. So I'll just leave it like that. But yeah, just a conclusion, just a few questions that I was thinking of. So is this just a matter of downloading a few files and clicking go? Because that's kind of what it was. It was just downloading the model and getting some training data. But I think it's more of picking the implementations of what you want that to do. And I think sometimes, especially when you've got open source models and stuff like that, it's easier sometimes than building your own model, especially if you've got minimal training data like I did in this case. And then are the images stored in the model? So no, they get turned into an array and in the model. And then is it easier to adapt a model than build one from scratch? Which yes, it is. And for my purposes, it was much easier for me just to take an already established model and add my own images onto it. Whereas if it was doing it for more sort of a bespoke case, such as like self-driving cars and the NHS, which they've been used for, then you'd build a model for that rather than just using a pre-trained one. So yeah.